Two-step equations aren't hard. I've looked around on the internet and I've looked for videos using number bonds. And number bonds are always used in elementary school, but why aren't they being used later on to teach one-step, two-step equations, multi-step equations? If anybody has a video on it, I want you to send it to me because I haven't seen it. I'm going to show you how to do it using number bonds. Number bonds are the best deal in math, and I'm going to show you that as well. But why do we have to learn about two-step equations? That's all I get from 7th graders. Why? Well, if you have to save $50 for something, and you only have, I don't know, 18 bucks in your pocket, but you have a job that makes $8 an hour. Now forget taxes and everything else they take out of a paycheck. Let's say you bring home $8 an hour every hour. Well, how many hours do you have to work for? There's a real world example of a two-step equation. Let's understand the math language before we start anything else. An equation. An equation is a mathematical sentence that contains an equal sign. It has to have an equal sign if it's going to be an equation. A variable. What the heck's a variable? Well, it's a letter that's used to represent one or more numbers. If you have the same variable in an expression, you can combine them together, and we'll talk about combining like terms. Additive inverse. This is the most important when solving equations. You have to use additive inverse to create 0 and to balance the equation out. It's a pair of numbers whose sum is 0. What's a term? Well, there's terms all in equations or expressions. And since we're talking about equations, terms could be the number of x's that you have or y's that you have, or it could just be a number, a positive or negative number, fraction, decimal, something like that, that doesn't have to have a variable. And then combining like terms. I told you we're going to talk about this. When we combine like terms, we're putting terms together that are the same. Any letters that are the same, we're going to put together. You can see in this example, we have 2 x's on the left and 7 x's on the right. When you put those together, a lot of people make the mistake and say, oh, there's only 2 x's because there's 2 terms that have x in it. No, that's not the case. 2 x's and 7 x's. How many of the letter x do you have total? That would be 9. And you're going to combine terms. Terms can be combined together if they're just numbers with no letters at all. That's the other thing. Finally, a number bond. A number bond is a model showing part-whole relationships. Basically, in this example here, 6 is your total, and then you have 4 and 2. Those are pieces. We're going to talk today about the pieces that make up a whole. And with equations, it goes the other way. They give you the whole, and you have to find one of the pieces or one of the parts. Why did I just say that number bonds are the best deal in math? The best deal from kindergarten right on through. Best deal in math. Let me make it very simple for you. I have developed number bonds to work in my 7th grade class. So you can see that it's a little bit different for me, but it helps kids write equations and move forward with so many different aspects of equations as we go on through the year. The first thing that I want to bring to your attention is total. The total is the key. Let's just use simple numbers like the number 8, okay? You can see here I have an unknown. Right now, we're not going to deal with an unknown. I'm just going to give you a number. What we have to know is between these 2 number bonds, we're adding them together, okay? The number 5 plus the number 3 will give you the number 8. Well, what we understand with number bonds is that we can go very simply, 5 plus 3 equals 8. Simple arithmetic. And we could go the opposite way. Instead of 5 plus 3, we can go 3 plus 5 equals 8. But we can also go the reverse way. Start with the end in mind, the total. If we start with the end in mind, we can go 8 minus 5. Now, if you're me in 7th grade, I hate students using subtraction. We deal with positive and negative numbers all the time. I want them to change it so it's 8 plus a negative 5. And that's still going to give us positive 3. And we can go the other way. 8 minus 3, or 8 plus negative 3, equals 5. Nowhere else in math are students going to be able to understand 4 different ways to set up and solve a problem. Number bonds give it to us. So why aren't we using them more? That's teaching number sense. That's what we need. We need kids to think differently. So let's do it. Let me show you how to do it with two-step equations. The equation's already written for us. I'm going to put it on the line so you can see step by step how solving a typical algebraic equation happens with the use of the number bond. I've got 21, and it doesn't matter what way that they set it up. This is the best part. 21 is equal to 9 plus 2r. These are 3 terms that we have. 21 is a term, 9 is a term, 2r is a term. And we got to make sure that we understand is that 2r is 2 of the letter r. There's 2 letter r's. That's what they mean. Instead of writing r plus r, they just combined them together and got 2r. Where do these terms go in the number bond to help us set it up? Well, we're always going to put our plus sign here. We're always going to put our minus signs here. And we have to understand that the total is always equal to the 2 terms that we have here added together. Okay? I'm going to erase that, though, for now. The total is 21. They gave us that. They gave us that. That's the difference between algebra and arithmetic. All right, hold on a second. Let's talk about the difference between algebra and arithmetic for a second. Time out.
We call a timeout.
Simply put, arithmetic is simple operations. 9 plus 1 equals the end, the total. Algebra is where they give us the end, which is 10, and they want us to find a piece or a part that combines, in this case, with 9 in order to give us 10, to get us the total. Arithmetic, you're finding the total, and you already have the pieces. Algebra, you know the total, and you know maybe a few of the pieces, in this case, 1 of the parts, but you're finding that other piece, that other part that will combine to give you the total that you want. All right, time in.
Time in.
So 21 is our total. We're going to put that there. The part that we already know in this equation is 9. These are the pieces that are going to make 21. So I'm going to put 9 here. And then my unknown, I have 2 letter r's. Like I said, this is r and r added together to give us 2r. That's it. Okay? Now, everyone gets hung up on, what's the first step that I do? Well, just look at your number bonds. Can you take r's and subtract them away from a number? No, that comes to common sense combining like terms. You can't take letters away from a number, but you can take a number away from another number. You can take 9 away from 21. How does that look like in our traditional way of solving this? Well, here's our additive inverses that we were talking about. We want to make 0. I cross it out and have my students cross it out with a 0. And then when I take 9 away from 21, I'm going to be left with 12. If I bring down my equal sign and bring down my 2r, now comes the division part. We want to split up those r's, which means anytime we say split up, we want to make sure that we divide. When you divide r's, I have 2 of them. I'm going to write them both out. So I have 1 r here and 1 r here, which means I've got to divide up 12 evenly because I want my r's to equal the same amount. 12 divided by 2 is going to give me 6 for each r. So you have solved, and we have solved, the first equation for you using number bonds that r has to equal 6. Here's one more for you. Let me set it up. 15 plus 2s, this is another good different look, equals 47. Whatever it equals, that's our total. 47. What do I already know? I already know 15, so that's going to go here. And I know my unknowns are 2 of the letter s's. What do I do first? Well, These can't get combined together because they're S's in 15. I can't take S's away from 47, so the only move that I can make is take 15 away from 47. Additive inverses create 0 on the left side. On the right side, I'm going to go ahead and subtract, and I get 32. So I have my 2 letter S's equaling 32. I know that I've got to divide my S's up into individual S's. 1, 2. Both of these S's are going to end up equaling 16 because 32 divided by 2 is 16. Guys, this is the basic form of two-step equations using number bonds. Check out the other videos that I'm going to post for you that deal with different ways that two-step equations can look, multi-step equations can look, distributive property can look. ParksMath.com. Guys, show me, email me in the description below. Find my email address and email me any link that you find that somebody else is doing number bonds and solving two-step equations with them, multi-step equations with them, because I can't find it. Make sure you give me a thumbs up if you like this, if this helped. Share it with somebody else, please. Just one person, that's all I ask.